Think about what the word inheritance means in English. Something which is passed down from one generation to another in a sort of parent to child or original to new way. This could be a name or a language or any kind of property like hair or eye colour. This doesn't just apply to people, but to objects as well. We might say that a new model of car has inherited certain design features from the cars that came before it. Things like having 4 wheels, a fuel tank, and a steering wheel. These are all things we think of as being fundamental to what a car is. In object-oriented design, inheritance means much the same thing. One class can inherit certain attributes from another. Let's take a look. Let's write a class for a car. We'll have some properties which are set in the constructor, and some which are set as defaults. We'll also include a couple of methods. Now let's say we want to write another class for a specific model of car. Instead of copying out the whole definition again, let's use inheritance. This is the syntax Python uses for inheritance, starting with the opening line of the class definition, with these brackets that we haven't seen before. It's in these brackets that we put the class we want to inherit from. The syntax is very similar to writing parameters in a function, but don't get confused, they mean different things. One is for function definitions, the other is for class inheritance. Inheritance means everything car does, palcar will also do. If we were to just leave it here with no further definitions, it would be completely identical to car. We call this a subclass, which makes the original car the superclass. If we change the superclass, the subclass would be changed as well. From here, we can add new attributes to palcar, like methods and properties. Let's add a method for beeping the car horn. Now let's see how these classes work. We'll create 2 objects, one of the supercar class and one of the sub-palcar class. We'll see that we can access any method or property of car from the subclass, but if we try and access anything specific to palcar from the car superclass, we'll get an error. So far so good. We can inherit from a class and add new properties to the subclass. But what if we want to override properties of the superclass? Let's say we want every palcar to be purple. Remember that car takes color as one of the constructor parameters, but we don't want this to be an option for palcar objects. To do this, we would need to overwrite the constructor. Overriding is essentially redefining or replacing an original definition with a new one. Here we've written a new constructor for palcar, which will override car's constructor from which it inherits. See that now, color is no longer accepted as an argument. It's always set to purple by default. When you override an attribute, it will be overridden for that subclass only. The superclass is unchanged. In Python, you don't need any special syntax for this. It's written just the same as any other method definition, but you do need to make sure that you've gotten the name right. If the name doesn't match the original property or method of the superclass which you're trying to overwrite, you won't have actually overwritten anything. You'll have just defined something new, and the original will still be there. Rewriting an overridden method is good if you want to completely change how it works, but here it seems kind of unnecessary. We're just changing one thing after all. Remember what we've said before about wanting to reduce redundancy in our code. Say something once, why say it again? Luckily, there is a solution. In Python, we can use a special method called super. Super allows a subclass to directly access any attributes of its superclass. In Python, we use a special method called super. Super allows a subclass to directly access any attributes of its superclass. We do this by calling whichever method or property we want from the super call, like this. This helps us with our car example. Instead of rewriting the whole thing, let's just call the super constructor, but this time passing purple as one of the arguments. The super constructor will run as normal, just like we already wrote it. Notice that this time we did explicitly call init by name. Normally, this is done automatically. Calls from super are one of the few times you will need to do this for magic methods like init. One class can have multiple subclasses, and those subclasses can have subclasses of their own. This can grow into very large family trees of classes, which have their own uses and levels of complexity. all inheriting from one common superclass. We could define flying cars with no wheels, self-driving cars with no steering wheels, even a super pal car subclass which you would never need to refuel somehow. Can one class have multiple superclasses? That is, can a class inherit features from two different classes? The short answer is yes. Python does allow for multiple inheritance, although not every language does. This is because it introduces some problems. What if the two parent classes have conflicting properties, or two methods with the same name that do different things? How would the child class know which one to inherit from? Python gets around this by having something called method resolution order. If there is a conflict, one class takes priority over the other, as determined by the order in which the superclasses were listed. Multiple inheritance isn't very common, likely because Python is one of the few languages which supports it, and also because it can get pretty messy. You won't use it in many cases, but it does have a few super interesting niche uses. And these could be worth having a play around with once you've gotten comfortable with the fundamentals. Summary. Class inheritance is a super useful tool for big programming projects. It gets used everywhere, from video games to web apps to machine learning. You'll see it a lot, not just in your own code, but in the design and documentation for programs you'll be using for yourself. So, understanding how it works is extremely useful in your ongoing coding journey.